Hello, friends. So, let us start our journey with the Azure Data Engineering program. And this is the session one in the entire series. Now, in this course, I would like to talk more about data engineering aspects, and we would start with the basics, but basics of Azure, which are normal to any cloud, is not the is not the main thing that we will be focusing on. The major part where we will be going into a lot of depth would be data engineering related components, for example, data factory, data bricks, or the storage part of it, things like that. So, synapse analytics is also very important. So, basically, we would start with the fundamentals, right? And then we will s- start picking each topic from a data engineering perspective and will deep dive into that. So, let us start. In this session, we will talk about some of the fundamentals like what is cloud, right? And how exactly it is different than on premise and things like that. Because some people I understand might not be coming from a cloud background also. So let us quickly start. So, the very first thing I would ask you, what is not cloud computing? I'm not asking what is cloud computing. I'm saying what is not cloud computing? What is not cloud computing? This is the first thing that I would like to ask. Consider, let me give you a very simple example. Consider you have to create a big data cluster. You have to create a big data cluster. This is what you want. And you have to create a 40 node cluster. 40 node cluster. This is what you want. Okay. So you want to create a 40 node cluster. Now, let's not think about cloud and all. What would you do if there is no availability of cloud? Some people might be thinking what they will do when cloud is available. But I am thinking, let's not worry about cloud and all. What you will do generally? You might buy these machines. That means buy the 40 nodes. When I say nodes, it means machines or servers. You will buy 40 servers, bring it at a place, right? You will then install the desired softwares, right? You have installed them. Let's say you might install Cloudera, Hortonworks, MapR, or anything, whatever you want, right? Then you would have to maintain those servers in the sense you might have to apply security patches, you might have to install software updates, and number of things like that. And you should also have a IT team who do that, because you are not the one who will install manually. You should have set of people who know about how to install, how to handle the servers and all of it. Apart from that, what else you need? You might have to have a small place where you should be keeping this 40 nodes. That means you should have let's say uh, infrastructure. When I say infrastructure, mean to say a building, let's say, or a compound where you have to keep all of these things. You should have enough cooling capacity, cooling power, right? Because when you have these many servers, definitely you need cooling equipment so that all these things, kind of the temperature does not raise, all of these things. And a lot of stuff, cooling, power, all of this is required in order to maintain it. It's a big headache, believe me. And after doing all of this, if you have done all of this very nicely, and tomorrow you realize that, okay, I want to extend this to a 80 node cluster, then is it easy? You, let's say, plan to have a 80 node cluster, let's say tomorrow. Is it easy to do that? No, because again, All these things what you have done, you should be doing with the other 40 machines. You have to buy them, and you cannot buy them in a day. It takes several weeks for you to get those machines. Then you should be installing them, maintaining them, and all of it. It's a very, very tedious approach. And then when you have made it to 80 node cluster, tomorrow you feel, oh, 80 nodes are not required, I need only 20. What you will do with remaining 60? So if you feel you do not require 80 machines, 80 machines or nodes, then the remaining resources go idle. That means there is no choice for you now. Even if you want to just work with 20 nodes, you have purchased extra 60, and this computing power and all will all go wasted. So these are the challenges when you try to build such a system by yourself. And this is what I'm talking about, is not cloud. This is called on-premise environment. On-premise. That means this is on-premise. When I say not cloud, means on-premise. That means in your premise, at your location, you would be purchasing few hardwares, right? You will be installing everything manually. You will have enough cooling equipments, power, all of it. You will have a team to handle all of this. And might be when the requirement goes high, you have to purchase it again, do all of those procedures again. And when the requirement goes low, then you end up wasting your resources. And it takes, I mean, months to get all of these things in place. It's not that in a day if you want something it will happen. It does not happen that way. So it is a very tedious task, and if we start doing it, probably then the focus from actual business goes away, and then we end up just thinking about this. I hope you can understand what I am trying to say. Right? So this is the challenge with on-premise systems, where we try to do everything ourselves. Just have a look at the notes that I have written. Okay. So these are the things that you need to consider, that these are the challenges of on-premise basically. Now talking about, let's say, big billion day. Flipkart every year has a sale called as Big Billion Day. You know that. I think the sale is in December month. I am not too sure, but I think it's in December month. Now, whenever we have that sale, probably let's say Flipkart is operating on 100 servers earlier. But when the sale comes, it might have to triple the capacity, or it might have to operate on 300 servers. Now, if they are doing something on premise, then they would have to again buy those servers and do everything by themselves, which is super tedious. So, what they can do probably, or what they might be doing, is that they might be using some cloud environments where they can just scale up or scale down based on the needs on a click of buttons, right? Because when the requirement goes up, you might have to buy the things. When the requirement goes down, then there is no way of selling it, right? When you are going with on premise. So that is where the role of cloud can be handy, where we do not try to build all of this setup by ourselves. We say, is there a way someone can provide us these things and we can just use them in very layman terms, right? So I hope you have got some idea that what are the challenges with on-premise, and at a high level, you understand what is cloud. Cloud says whatever infrastructure, softwares, all of these things, what we are trying to do at our end, is there a way someone can give it to us and we just connect to it and leverage the service? I hope this should give you some clarity. Let me tell a formal definition of cloud. What is cloud? I've explained you, but now let's go with formal definition. So we can say it is on demand availability of computer services. Computer services like servers, data storage, networking, databases, etc. That means any of the service, whatever we need on demand, can we get it? Right? That's what we are asking. And what's the main purpose of the cloud? Is to give access to data centers to many users. That means whatever data centers we have publicly built, many users can leverage that. Right? So users can also access data from a remote server. That means, let's say my data center basically is a place where these cloud providers will have all of these setups, right? So data center is the place where the servers are set up, right, by cloud providers. Basically one big room or hall where, let's say, they have put all of this servers, done the networking, having the storage, installed the software so that we can use them, and then a remote user can connect to any of the service through internet, right? So users can access data from a remote server or any of these services from a remote server. So this is how it goes. So basically, if I want to build a cloud service for others, what I would do, I would set up all the things at my place and then allow the users to connect to these services or leverage these services through internet from wherever they are in the world. Right? That's how we have to build cloud service. Now, we can give a other definition also. If someone asks what is cloud, we can say it's a service delivery model over the internet. Cloud is nothing but service delivery model over the internet. That means we can use a virtual machine, we can use database service, we can use a function app, so many things, whatever we can use. There are n number of services. We do not have to worry. But any of these services can be leveraged over the network. I hope this is clear. Right? So service delivery model over the internet, and majorly what are the things? Basically compute, storage, networking. These are the main things which are there. There are n number of things, but generally when we talk about, these are the main things: compute, storage, and networking. Okay, so with this probably you would have got an idea of what is cloud, and you would have understood what is on-premise. So if someone asks you, oh, what is the difference between on-premise and cloud? You know that in on-premise, you would set it everything at your place. You would take all the pain of doing it yourself and just bothered about it, right? Because it's not that once you have set up, it's done. After that, regular maintenance and all of this is a big headache. But small startups who really do not want to invest time in doing these things, they say that I want to focus on my business logic. Why should I even worry about how to set up my infrastructure? I will just take these services with a cloud provider, pay them based on what services I use, and I'm done. And tomorrow, when my load increases, I can even increase the capacity. For example, I might be using 10 servers, I can use 100 also. For 2 hours, let's say if I require 100 servers, I basically use those services, pay based on the number of hours I have used, and then again reduce it to 10 servers. I do not have to really worry. I only have to pay for what I use. It's not that I end up paying for the services which I am not using. That's the beauty of cloud. I hope this is good. Okay. Now, what are the main cloud providers which are there in the market. AWS, right? AWS is by Amazon, GCP by Google, and Azure by Microsoft. Right? These are the important or the famous cloud providers right now. Among them, you might be aware AWS is the market leader in a general sense, right? Because it started roughly in the year 2005. This is when they started. Azure started in 2010. But trust me, the way Azure or Microsoft is picking up, the difference is very less now. And if you see year over year growth, Azure is having a higher growth compared to AWS. And when we specifically talk about data engineering services, check most of the JDs, they would look for Azure. And less of them are looking for AWS these days. I'm not saying AWS is not important. AWS is the market leader in a generic way, but when we talk about data engineering, Azure has picked up the market better than AWS in the current times, right? And that is why I plan to design this course on Azure, not on AWS. Many people were asking me, sir, what made you to choose Azure over AWS? The reason is Azure is having a better demand in data engineering today, right? And the way it's growing, the demand for Azure will be even higher in future compared to other service providers, right? And just to let you know, there are many other clouds, for example, IBM Cloud, right? And Oracle Cloud, which are, going well, but not as big as these three. Fine. So this should be good, I feel. And that's the whole reason why I selected to create a course on Azure, not other things, because of the market demand. Now, talking about on similar lines, CapEx and OpEx. CapEx versus OpEx. CapEx stands for capital expenditure. Capital expenditure. OpEx stands for operational expenditure. Okay. Now, when we talk about capital expenditure, what we mean to say? We mean to say we have to put, the very high amount in the beginning to start with, right? And operational expenditure means that we have to, put some operational charges slowly and steadily, right? So in this, one big amount to start with, and here amount, some minimum amount regularly to maintain things, right? So if you see this one, when we talk about capital expenditure, the on-premise systems is an example of this. On-prem. And when we talk about operational expenditure, we talk about mostly cloud, right? Why? Because when we talk about on-prem, you have to purchase the servers yourself. So a big investment is needed initially. Big investment, right? When we talk about cloud, there is no investment needed in the upfront. So when we talk about upfront cost, right? And we have, let's say, here we can say on-prem and cloud. Okay. So when we talk about upfront cost in on-premise, what do you feel is the cost required? It is quite significant, right? A good amount of cost because we have to purchase the servers. But in case of cloud, is there any upfront cost required? No, none. No cost required. When we talk about ongoing cost, in case of on-premise, the ongoing cost would be low because we might have to slightly maintain the servers, fix patches, and things like that. So, slight cost would be required to maintain. But in case of cloud, the ongoing cost would be based on usage. That means we end up paying based on our usage. So, based on usage, right? Early termination. Early termination. When we talk about on-premise, can we terminate things early? Let's say you purchase a 40 node cluster and you felt, no, I do not need it now. Is there a way you can go back now? No, right? That means there is no way that you can terminate it early when you realize things are not working out. There is no way. But when we talk about cloud, then of course you have not purchased anything. You can terminate anytime you want. Anytime. I hope this is clear, right? And in the maintenance, when we talk about on-premise, maintenance cost is quite significant. But in case of cloud, is there any maintenance cost? Are you going to maintain the cluster? No. Someone else will be fixing the patches. Someone else will be, looking at the security aspects. You do not have to do that. So the maintenance cost is super low or negligible, basically, right? And when we talk about value over time, in case of on-premise, let's say you purchased a laptop today, don't you feel the value of it will decrease in 5 years? Of course. With any hardware that we purchase, the value lowers down. So the value will lower down. But in case of cloud, have we purchased anything? No. So what is the point of value over time? No change. It's not that we are losing anything here, right? So basically, this is how cloud is beneficial over on-premise, where companies say that, oh, why should I take care of, getting this 100 servers, hiring or renting out a building space, putting those and putting some cooling equipments. Why do I require that? I do not require. I can procure this over a cloud on click of buttons, use it as per my convenience, and that should be the way, right? So pay as you go is what you say in terms of cloud. Very, very important. Pay as you go. So with this, probably you would have understood what is on-premise, what is cloud, capex and opex, benefits of cloud over on-premise, and how does it help. So with this, we can wind up the session. In the next session, we will talk about the characteristics of cloud. So I'll stop the recording and I hope you liked it. Thanks a lot.